In this section, we'll be creating our player movement system from scratch. We'll create a navigational mesh and begin working on a point-and-click to move system to detect the floor and move our player to the assigned destination. We'll wrap up by creating a camera follow system throughout the map, as well as activate switch points to keep our player in view. So in this video, we're going to set up our floor so that our player can walk on it. So in this game, we're going to be creating a point-and-click character controller. And in order for us to start doing that, we need our character controller to be restricted to the floor so that it can navigate the arena. So in order to do that, we have to use the navigational system of Unity. If you remember from the first course, The Ultimate Guide to Game Development with Unity, we use navigational meshes to create a path that our player can walk on. So if we look at our current scene here, we have a lot of floor space, and what we need to do is we need to bake this floor space so that when we create our character, it will know where it can navigate to. So if we click outside the map, or if we click on a cabinet here, it knows that it can't walk to that destination. So the first thing that we want to do is let's fix our layout here. For the most part, we're done with Timeline and Cinemachine. We will be revisiting it when we create the activation of the timelines, but for now, let's get our original layout back. So go to the right here, the right corner, go to Layout, go to Tall, drag your game view below your scene view, give it about a 50-50 level, and then in the project view, select this hamburger menu and change it to one column. This is going to give us our beginning production workflow. From here, guys, we need to bake this floor. So if you actually click the floor, it's going to bring you to this floor game object. And we actually created something for you called a floor collider, which is right here. So it's under your objects and then floor collider. And this is a custom collider that was designed specifically for this level. And what we want to do is we want to bake this object. So in order to bake this object, all we have to do is keep this object selected, go to Window, Navigation, and from here, what we can do is we can, with the object selected, we can go to Bake, and we can select Bake. And this is going to turn our floor blue. It's going to find all of the flat surfaces of our collider, and it's going to add this blue overlay. And this blue overlay is going to represent what our player can and can't walk on. It's also going to be representing for what our AI can walk on. All right, so we're going to be using this nav mesh throughout our entire game. And as you can see here, it perfectly maps everything. Okay, so the next step is setting up our character controller. So I'll see you in the next video. In this video, we're going to set up our character controller so that we can then create the point and click functionality. Now, before we can actually set up our character controller, the way this is going to work is we have this part of the map here, and that we're going to have a camera system that's going to follow Darren as he progresses through. So the game's going to start here after the cutscene. Our camera's going to be facing this doorway here. Darren's behind that case. The guards will be patrolling, and we need to click, and wherever we click, Darren is going to move to. Now, in order to get our starting position and our camera system set up, the way that's going to work is if you look inside your hierarchy here, we have, I believe it isn't. We have here a game object called camera progression angles. And in here are 6 progression angles. And we're going to have triggers on the ground, which are already set up for you. We're going to be coding in these triggers that basically every time you modify or every time you touch one of these triggers, we're going to switch to a new camera rotation. Okay, so we have our first camera rotation, which is going to be this one here. This is camera 1. This is where the game is going to start. So to align our main camera with this is a local position versus a world position. So what we need to do is we need to take our main camera, place it in here, take the transform of the camera 1, copy that component, paste it by right-clicking, and paste component values over the transform. This is going to give us our start position for the main camera. After that, you can move the main camera back out of the hierarchy or back out of the camera progression angles. So here we have our main camera, and we have our starting view. So this is going to be the start view for us. And from here, we can now create our character controller for Darren. So let's go ahead and just prototype it out. We're going to have a game object, a 3D object. It's going to be a capsule. So go ahead and zero out the position. Let's find it in our scene. All right, it's over here. Go ahead and move it to behind the staircase, or I'm sorry, behind the casing that Darren is communicating behind during the cutscene. So that's going to be over here. All right, so he's going to be right here. All right, and what we can do now is we can also increase the size of this. So let's go ahead and make this about 2 on the Y. And maybe 2 on the X as well to keep it consistent. All right, we want to see how that looks. All right, so that looks actually pretty good in the game view. So 2 on the X, 2 on the Y would be fine. If you want to keep 2 on the Z, you're more than welcome to as well. Okay, so here is our capsule. This is going to be our player. So let's go ahead and rename this to player. Let's also give it a tag of player. So if you drop down the tags here, we have player. Okay, so we have Darren, and what's going to happen is we're going to be able to click in the game view somewhere, and Darren's going to move to that position. Before we can do that, we need to make sure that he acknowledges that he is attached to a nav mesh. So in order to do that, we need to add a nav mesh agent, and this is going to lock him to the navigational mesh. So you'll see here that even if he starts up in the air here, because he has this nav mesh agent, when we run the game, he's going to snap to the nav mesh, and that's going to keep him from falling through the floor and doing anything that we don't want him to do. And there you go, he snapped. So he can only move across this nav mesh in the respectful places. All right, so that is our player setup. He is strapped to the nav mesh, and the next section we will look at the logic for creating a point and click character controller. In this video, we are going to create the point and click functionality. So the first thing that we want to do is create a scripts folder within our game environment. So open up your Great Fleece, game, and let's create a new folder. Call this folder scripts. This is going to maintain and host all of the scripts for this game. Right click that folder and let's create a new C# script called player. Once you have that created, select your player and drag this component onto it. You can also go to add component and search for it. All right, so now that our player has our player component, it's good to go. So what is it that we're trying to create here? We're trying to create a system here that when I left click, Darren, our capsule or player, will move to that position. So in order to do that, we need to use raycasting, and raycasting is going to allow us to cast from our mouse position to the floor. We're going to get a position that we hit, and we're going to tell Darren he needs to move to that position. And in order to move Darren, we have to look up how to do that through the nav mesh agent, because in order for him to move, we have to modify the nav mesh agent because he's stuck to the nav mesh, so we can only move him through this nav mesh agent. So the first thing that I want to do is I just want to get the position of where we hit. All right, so the logic here is if we left click, let's get the position of what our raycast hit so we know where Darren needs to move. So let's open up our script and write out some pseudocode. And if you remember from my first course, pseudocode allows you to basically write out your ideas and your thoughts in English and just transfer them to code very easily. So let this load up. We'll go ahead and align our program. And the first thing that we're going to be doing here is in update, we're checking if you left click, right? So if left click, right? So that's going to be an if statement. So if you left click, what do we need to do? We need to cast array from mouse position, and then we want to debug the position of it. So debug the floor position hit. All right, so that's all we want to do. If you're familiar with raycasting from my first course, you know that there are two parts to raycasting. You have a ray origin, which is the starting point of your ray, and then you have a raycast hit info variable, which stores what you hit, and you can get the position of the object you hit. So that's exactly what we want to do with our floor. So we're going to left click, we're going to cast array from the mouse position, and then we are going to debug the position values that we hit. And as an added challenge, if you wanted to, as an added challenge, go ahead and create a game object that you hit. So debug the floor position you hit, and then we're going to create object at floor position so we know where Darren should be going. All right. To get you started, guys, if you're not familiar with raycasting, that's what Google is for. head on over to google.com, type in raycasting, and from here we can go to raycasting. They have some tutorials on raycasting, but we want to actually look at the documentation. So let's go raycasting in Unity, scripting API, physics.raycast. And in here, you can see how do we cast a ray? Well, it starts with if physics.raycast. And the reason for that is because it's an if statement. Did you hit anything? A raycast just detects a 3D, it's just a 3D line that detects intersecting collisions. So did that line hit anything? If it did, there is something in front of the object. You can create a message. We have other examples in here, such as this was here is casting a ray from the transform.position of the player. And then from here, it has a direction, and then it's using the out hit. So whatever it hit, that object is being stored in this variable called raycast hit. And if we continue looking at this, you can see here that we actually have an example that we're interested in. For instance, we need to cast a ray from our mouse position. So we have a ray origin, which is casting from the camera. It's going to cast from screen point to ray, and it's going to cast from our mouse position. If it hit anything, it's going to print out hit something. What I want you to do is I don't want you to print out hit something. I want you to print out the position that we hit, which means you also need to use the raycast hit variable. So if you have not taken my first course, the Ultimate Guide to Game Development with Unity, I highly recommend you do so as you get very familiar with raycasting in that course. All right, guys, I will see you in the challenge review. In this challenge review, we're going to look at how I would solve the point-and-click character controller. So looking at our pseudocode, the first thing we have here is if we left-click. So that's a simple if statement. And if we left-click, so we do input.getButtonDown, and we can pass in a number here. So input getButtonDown, 0 is for left, 1 is for right, 2 is for the scroll wheel. So if input.getButtonDown, and actually not getButtonDown, guys, I'm sorry. It is actually input.getMouseButtonDown. So when we do getMouseButtonDown, you can pass in an int, and it returns true during the frame the user presented the given mouse button. So 0 is for left click. So if you left click, so here we have if we left click, then what needs to happen? We're going to cast a ray from the mouse position. So I'm going to create a variable to store the ray, and this is going to be the ray origin, and that's going to equal our camera.main. That's going to be our main camera, so we're going to say camera.main.screenPointToRay. And this is going to allow us to cast a ray from our screen point from our mouse position to the world position. So screen point to ray, we're going to say input.mousePosition. So wherever we click, we're going to cast a ray. And what I would like to do now is I also want to make sure that I can, whatever I hit, so if I hit the floor, if I hit a casing, if I hit a guard, I want to return what I hit. So we need to say raycast hit, and we're going to call that hit info. So whatever I hit is going to be stored in the hit info. So we cast a ray from mouse position, right? So we did that. The next thing we need to do is debug the floor position that we hit. So we're going to create an if statement that checks if we hit something. So if physics.raycast, and you can see here we're going to pass in our ray origin, and we have 16 options here. So we're going to pass in our ray, which is our ray origin, and we want to just output the hit info. So looking at the selections here, and your tooltip is one of the most important things of Unity here, you always want to use it, is we're just looking for casting our ray, and we just want to output the information. So if we'll use number 3 of 16, you can see here that it's asking for a ray and a hit info. So here we're going to pass in our ray origin. We're going to hit a comma. We're going to say out, and then we're going to put it into hit info. All right, so whatever we hit is going to be stored in hit info. And from here, we can go ahead and say debug.log, and this will print out hit, and then we want to know the position of what we hit. So we're going to say hit info dot point. And this is going to be the position, the impact point in world space where the ray hit the collider. So where on the floor did we hit? We're going to get that exact position. Let's save this. Here's debug the floor position hit. Let's save that, test it out, and then I'll show you how we can create an object of where we click. So we have an error here, unexpected symbol. And it looks like we have our if raycast hit, It looks like I may have an extra one possibly. And I'm actually missing a parenthesis here. So for every open parenthesis, you need a closed parenthesis. Let's save this. Head back into Unity. Let's run our game. And you'll see here in the console on the bottom left that wherever I hit, it's going to print out a position. So hit position 4, 2, 2, and 23. And you can see here, as I move across the map, it's giving me position coordinates. And we're going to use these position coordinates to tell our player where to go. Now, what if I wanted to, say, spawn a cube wherever I hit? The way we can do that is Unity allows us to create dynamically primitive game objects. So what we can do is we can actually open up our script here. And we can create an object at the floor position. So here, if we hit something, let's go ahead and add a cube at where we hit. So for instance, we can go ahead and say game object, and we'll call this cube equals game object dot create primitive. And this will allow you to create a primitive type. So we're going to say primitive type dot cube. So you can choose capsule, cube, cylinder. These are just built-in object types of Unity. So by doing this, what's going to happen here is it's going to create an object and it's going to assign it to the variable cube in our hierarchy. From here, we can grab that cube and we can set the position of that cube. So we can say cube.transform.position, and we're going to set that to wherever we hit on the floor, which is our hitinfo.point. Let's save this. Now every time we click, we're going to create a cube. So check this out. We'll run the game. And no matter where I click, a cube is going to spawn. And you can see them here, these little cubes. So this is going to be a path for our player. So we'll know exactly where we hit and where our player should be moving. All right. That wraps up this challenge review. In the next video, we are going to look at adding movement to our player so that he follows where we're clicking. In this challenge, we need to move our character when we click. So currently, what we have is we can go ahead and place these boxes on the ground. However, our character isn't moving. So in order to move our character, we need to look at how to move a player or a game object along a nav mesh. So how do we figure that out? Well, simple. We have this nav mesh agent. Let's go ahead and open up the scripting reference for this. To do this, you can go to Google. And let's simply search for how to move a player along a nav mesh. So how to move a player along a nav mesh. Now, it's very important when you're researching information, you never copy and paste lines of code. You don't want to copy and paste it. You want to ensure that you actually understand what it is that code is doing. So here we go, how to move. And you can see here that there is a Docs Unity 3D manual on telling a nav mesh agent to move to a destination. That sounds like exactly what we want. And it says here, you can tell an agent to start calculating a path simply by setting the navmeshagent.destination. And here's an example. They're using getComponent to create a reference to that navmesh agent. And if we look on our Unity here, you can see that our player has a navmesh agent. So they're getting a reference to that component. And then what else are they doing? And then here, not only are they getting a reference to that component, but they're setting the destination. So here they say agent.setDestination equals goal.position. And .position is a vector 3. So if we didn't have, so what is the position that we want to set the destination to? The destination that we want to set our position to is whatever our hitinfo.point returns. So wherever I click, that's the destination point. So this should be pretty much all we need to be able to make this working, or to get this working. So opening up our script here, and we'll write out some pseudocode. All we need to do here is we need to create a reference variable. So we're going to create a variable to hold our navmesh agent, right? So we have a variable to hold our navmesh agent. We're going to use void start to assign that variable. So here we create a handle, right? So it's called a handle here. So we're going to have a handle to navmesh agent. And then what we need to do is we need to actually assign that handle to the navmesh agent component. And if you're struggling with getComponent, guys, the ultimate guide to game development with Unity has several topics on getComponent and gets you comfortable with getComponent. So here we assign that handle to the navmesh, and then what do we need to do? I'm going to comment out where we actually place cubes as we're no longer going to need this. But what we are going to do is if we hit something, I want to set our destination to that point. So we need to grab our handle and we're going to say set destination. So we're going to say whatever the variable name is of our handle. So handle.destination equals the hit info. So it's going to equal the hit info position or hit info point. Okay, so I will see you guys in the challenge review. Hopefully we have the same result. In this challenge review, I'm going to demonstrate how I would create the player movement along the navigational mesh. So the first thing we need to look at here is we have our player game object and we have a nav mesh agent component and our player script. So the first thing we need to do is we need to get a reference to this component, and then we can use the destination property to assign it a destination. And during your research, there's also a function called setDestination, which is very similar. So if we pull up the scripting API and we look at the navmeshagent.setDestination, the syntax for this one is you get a handle to the navmesh agent, and then you type setDestination and you open a parenthesis. When you're looking at the documentation, all that's really important is that you're looking at the syntax. Okay, I don't really care what their example is, but you can see here if you read their example that they're getting a reference to the navmesh agent, and then from there they're doing agent.setDestination hit.point. That's actually going to assign it a position. So that's really exactly what we're going to be doing. So let's go ahead, look at our code, and type this out. The first thing we need to do is we need to create our handle. All right, so we're going to say private navmesh agent to get that component, and you'll notice that it's not populating here. And the reason for that is because I don't have access to the AI library of Unity. If you look back at the inspector, or I'm sorry, if you look at the documentation, you'll see here that their component here is private AI.navmeshagent. Now, I typically don't like the syntax of writing out AI.navmeshagent, and this is just a namespace. It's a library. So what we can do is create that namespace for the artificial intelligence. So we'll go into our code here, and we can actually include a new namespace using unityengine.ai. And that's going to allow us to access all of the properties of the artificial intelligence system of Unity using the navigational system. So, and if you're not familiar with the AI, my first course, we talk about it. Or if you're not familiar with namespaces are just libraries of code. The reason why we can even type player inherits model behavior is because of this Unity engine namespace. It's just a library that allows you to access functionality of the engine. Another example is if you're creating UI elements, you're going to use the UI namespace to access functionality of the UI system. So it's just a library of code. So from here, now that we have that namespace, we can say private navmesh agent, and you'll see here that our tooltip is now populating properly. So private navmesh agent underscore agent. And once we have that variable or that handle, we need to assign that handle to the navmesh component. So we're going to go ahead and we're going to say underscore agent equals get component, and the component that we want is the navmesh agent off our player. So now we have a reference to our navmesh agent. So what are we going to do next? I'm going to delete all the comments we have here. The next thing we want to do is if we hit the floor, we know the position of that floor. Let's send our agent to that position. So we're going to say agent.setDestination, open a parenthesis, and you'll see here that it sets or updates the destination, thus triggering the calculation for a new path. Target, the point to navigate to. So vector3 target, it's looking for a position variable that it wants to move to. And that's going to be our hitinfo.point because that returns a vector3 of what we hit. So we're going to say hitinfo.point. Let's go ahead. Let's save this. I'm going to comment out our debug.log here. We don't need it. I'm just going to remove some comments here. Let's save this, head into Unity, and let's go ahead and test it out. So we're running our game, and you'll see here that when I click, our character intelligently moves across. Now, you'll notice that he is clipping some of the objects here, so we're going to look into that in just a moment. But you can see here that we have a fully functional click-to-move character controller. And as he approaches the point, he stops. Okay, so let's take a look here. In the next video, we'll go ahead and fix the clipping. So to fix this issue with colliding through objects, the clipping issue, it's really simple to fix. In your hierarchy, we have a game object called objects, and we have an object called detailed model. And you'll see here, as it's selected, everything is highlighted that's a 3D model. Our navigational mesh doesn't know that these are obstacles to avoid. So what we need to do is we need to mark them as static so that the nav mesh agent will know that we should avoid them. To mark them all static, select the detailed model. In the right here, there's a static button. Check that. Yes, we want to make changes to all the children. From here, hop into your navigation, clear your old nav mesh, and let's bake another one. It's going to bake, and because these are now static, you'll see here that there is a rim around each object, making it so that we can no longer pass through these objects because our nav mesh agent can only navigate on what is blue. So if we run our game now, you'll see as it starts up, wherever I click, our AI will intelligently get to that position. And there you go. All right, I will see you guys in the next video. In this video, we're going to create our camera system. Currently, if we run the game, we have a completely functional point and click to move character controller. But what happens if our camera or if our player goes out of view of our main camera? We have nothing that's telling it to update the position. The objective here is to get to the other side of the map, which means we can only do so by changing our camera position and angle so that we can continue seeing the map. Now, to do this, we've already lined up where we want you to trigger these points. If you look in your hierarchy here, we have something called camera progression triggers. And if you select that object, you'll see here on the ground that there are trigger points all along the map that tell you when you should update your camera's position. So what we've done is we've given you the guidelines to where we want this to happen when we want to trigger it. It's up to you to actually create the code functionality. Now, how do you know where we want to rotate the cameras to? So these camera trigger positions are going to trigger some code that say, hey, update the main camera to this position. But what is that position? Well, also inside your level colliders or outside your level colliders, we have something called camera progression angles. And in here are the angles and rotation and scale and position of your main camera. So when you go through the first one, your main camera should update to camera 1. When you go through the camera 2 trigger, it should use the camera 2 position, rotation, and scale. When it goes through the camera 3 trigger, you're going to use the camera 3 position, rotation, and scale from the camera progression angles. So these two game objects are going to work hand in hand. This trigger script is going to take the transform values of these objects and it's going to take the main camera and assign it to them. So that's the logic here to create this system. So as a starting point, what I would like you guys to do is together we're going to create a new C# script, and let's call this camera trigger. And we need to create a modular script that we can attach to these trigger zones. And all I want you to do right now is I just want you to debug.log what camera should be active. So right now we can go through 1 and 2 because that's all we can see on the screen. So if we open up our script here, you need to add this script. Here, let's open this up. Give it a moment. Okay, so on this script, it's really simple. So this is going to be a trigger script, so we don't need to void start and update. I'm going to remove this just to remove the clutter. And what do we want to do? The functionality of this camera trigger is that we need to check for trigger. So we're going to have, so check for trigger of player. So if the player were to interact with this object, what do we want to do? We need to update main camera to the appropriate progression angle. So update main camera to appropriate angle. And that angle, guys, comes from here. We have these camera progression angles. So if you trigger, so if you go through camera 1 trigger, we want to set the main camera to camera 1 position. And if we go through camera 2 trigger, we need to update the camera 2 position. And you don't need to create 6 different C# scripts to make this happen. We can do this with one script using a generic camera trigger modular approach. So to get started with this, guys, all we have to do here is let's look at our camera triggers here. Let's select them all and let's add a camera trigger script to it. They each have the same script. So as a challenge, to start this off, all I want you to do is check for trigger, debug.log, and let's go ahead and just debug.log, let's debug.log trigger activated. All right, let's keep it small. So check for the trigger, debug.log trigger activated. I'll see you in the challenge review. In this challenge review, we're going to solve the camera trigger setup. So the end goal of this, right, is that we are going to check for a trigger from the player, and then we're going to update the main camera to the appropriate angle. But in the meantime, all we care about right now is checking for a trigger with the player and just printing out debug.log trigger activated. To do this, we need to use a Unity method called void on trigger enter. All right, and this is going to add in collider, and then we have other. Okay, so other is going to be the object who collided with you. The next thing you want to do is you want to check if other is the player. So we only want to do a camera change if it's the player who collided. So if other.tag is equal to player, then what needs to happen here? We're going to just simply debug.log trigger activated. If any of these topics are new to you, I definitely recommend you check out the Ultimate Guide to Game Development with Unity, where we actually discuss how to solve this problem from scratch in Course 1. So let's go ahead and test this out. We can save this. And if we test this out, I'm assuming off the back that it's actually not going to work. And if it didn't work for you as well, and the reason for that is because if you remember from Course 1, and if you read the documentation on how onTriggerEnter works, and let's see if it works. So nothing got called, but I know there's a trigger there. And the reason why that happened is because if you remember in the documentation, triggers are only sent if one of the objects have a rigid body attached. So to do this, and also it's a trigger that we're checking for. So if we actually select our camera triggers, you'll notice here that isTrigger is not set to true. So therefore, we're not even checking for any collision. So trigger needs to be set to true. And then secondly, we need to make sure that we want to make sure that we add a rigid body, which is going to add the physics capabilities for checking for a collision. You can turn off gravity. Let's run this again. I have the camera 1 trigger here selected so we can see it. And you'll see now, as I run through that trigger, we should have a debug.log. And there you go, trigger activated. I'll see you guys in the next challenge. So in this challenge, what we're going to be doing now is we need to update the camera position. We know when the camera trigger happens. So what we want to do here is we can detect when the trigger is activated. But now what do I want to do? I want to say here, and we need to actually assign a camera position. So if the player collides with this, we're activating a trigger, and based on whichever trigger it was, we need to say, take the camera. All right, so we're going to say camera.main.transform.position, and it needs to equal one of these positions. So it needs to equal camera 1, camera 2, camera 3, whichever trigger this script is on. And right now it's on all of them, right? So we're trying to create this from a modular approach. So how can we keep this modular with one script, but it will know that if I go through camera trigger 1, it needs to assign the position and rotation of camera trigger 2. So here it needs to assign position of the right camera angle, and then also we need to say camera.main.transform.rotation. So not only are we adjusting the rotation or the position of the main camera, but we're also adjusting the rotation, and that needs to equal the right camera angle rotation. So this is the right camera angle position, and then here we have the right camera angle rotation. All right, so good luck, figure it out. Do not quit. If you have questions, check out the Discord channel or check out the Q&A and I will help you. But I'll see you guys in the challenge review. In this challenge review, we're going to finish up the camera trigger system and show you how to create a modular approach or a modular design to this. So what I want to do here is I want to assign the proper camera angle, right? And rotation and position of that camera. So to do that, the first thing I need to do is I need to know from this trigger, which camera should I switch to? So I'm going to create a game object, or I'm going to create a variable that's going to hold the transform of the camera that I should be switching to. So I'm going to say public transform, and we'll say my camera. Let's save that. Let's comment this out. And actually, we don't have to comment it out. Now we have a reference to this trigger's respective camera. So every trigger is going to have on it a camera that when you trigger us, you're going to switch to that specific camera. So camera.main.transform.position equals my camera.transform.position. And we're going to go ahead and say my camera.transform.rotation. Let's go ahead and save this. Let's head back into Unity. You'll see here that we have our player game object, or I'm sorry, we have our camera triggers here. Okay, so if we select our camera trigger, we have that camera trigger script. It's looking for a camera. So camera 1 trigger goes with camera 1 camera progression angle. So here we're going to drag that. If we select camera 2 trigger, we're going to put camera 2 there. Notice the modular approach here that I don't need a single script for each individual camera update. We're using one script and we're updating on that specific object which camera it should go to. So if we go to camera 4, camera 4. Camera 5 trigger, we're going to add camera 5 to it. And camera 6 trigger, we're going to add camera 6. Now, if I go through and I go through the 4th trigger, which is over here, all right, it's highlighted over there on the marble floor, it's now going to update my position and rotation to camera 4 because that's the camera that's assigned to that variable. So each script is going to act as its own instance. So now what we can do is we can go ahead and test this out. I'm going to take my main camera and I'm going to move it just a bit just so we can have a visual of this working. I'm going to move it over here to this side, and as I go through the first camera trigger, it should now update to the respective camera trigger or camera angle. So let's go ahead and run our game. I'm going to go through the first trigger, and you'll see here that my camera angle was adjusted. As I continue on in the game and I move towards the second trigger, you'll notice that nothing happened. Now, why would nothing happen? Well, if we compare them, you'll see here that camera trigger 1 is set to is trigger and it has a rigid body. Camera trigger 2 through 6 do not. So you need to add a rigid body, turn off gravity, and then check is trigger so that we can actually detect that we're passing through that object. Let's go ahead and save our scene. Let's run this again. As I go through camera 1, okay, as I go through camera 1, we update. As I go through camera 2 trigger, we update. So there we go. And as we progress through this map, we should be able to click all the way. We should be able to go up these stairs without any problem. And as we get to here, you'll notice that we aren't switching yet. So this, okay, and this actually could relate to another functionality issue with our camera controller. Our camera isn't looking at our player, and we always want it to be looking at our player so we can focus on where it's moving. So I think in the next video, this might solve some issues, but as we can see here, where is our next trigger point? Our next trigger point is this camera 3 trigger. We're almost there, and we just can't quite make it. And the reason for that is because we're not looking at the player, which would give us a more center-focused view. So in the next challenge, guys, we're going to go ahead and create a camera look system. I'll see you then. In this challenge, we need to always be looking at the player. So currently, we have our main camera here, and as we run our game, it's not looking at our player. So what we want to do is we need to create a camera look at script where we're going to have a script that its sole job is to just always be looking at the player. So let's create a new C# script and let's call it camera look at. Or let's actually call it look at player or just look at. You can do look at or look at player. All right, so we have our look at player. And I want to select my main camera. So find your main camera. And select it. And let's drag the look at player script onto the main camera so that it's added as a component. From here, we need to always be looking at our player. So for starters, this script has no clue who our player is. We want it to look at our player's position, rotation, and scale, or transform property at all times. So we're going to create a variable that's going to hold the object we want to look at. So we're going to have variable to hold the object you want to look at, which is like a target, right? So variable to hold the object you want to look at. And then once you have that variable constantly, so because we want to do it constantly, we're not going to use void start. That's only called once. We're going to use void update. Constantly needs to look at the player. So how can we do that? How can we tell the player or the main camera to look at our player? So if we research, how do we look at the player? What we can do is we can go to Google and let's type in how to look at player, main camera. So follow the player with camera, scripting API transform.lookAt. And let's see here what it says. Rotates the transform so the forward vector points at a target's current position. Kind of sounds exactly like what we want. The syntax for it is look at, open parenthesis, and you pass in a target. And you can see here the syntax is transform.lookAt, and then you would open a parenthesis. If we look at their example, what is it doing? This complete script can be attached to a camera to make it continuously point at another object. It's exactly what we want. You can see here, very similar to us, they have a variable that holds the target to look at, and then in update, they're using transform.lookAt. So in the challenge review, I will show you how to implement this. In this challenge review, we're going to be creating our camera lookat system. So the first thing we need is a target object to look at. So this is going to be public transform and then a target. From here, we're going to add public transform target, and our target is going to be our player. So we'll assign that in the inspector. And then from there, we're going to say transform.lookAt. Now my tooltip has gone away because it lost sync with Unity. If this ever happens to you, all you need to do is save your script, hop back into Unity, let it compile here, and then just go ahead and double click it to open it back up again. So here we have our transform, and that in that case it did not work that way. Another thing we can try is if we close this out, we can right click it and we can resync, we can refresh, I believe, this script, and that should work just fine. And if we double click it again, oftentimes you'll have to also, you can just close Visual Studios and it will come back up. So there are a few workarounds to it. It's going to prepare the solution. Yes. Okay, let's go back into our look at player here, and we're going to go ahead and type transform.lookAt. And if we open a parenthesis here, it's looking for a transform target, and that's going to be our player, which is target. Let's save this, head back into Unity, click on the main camera, and you'll see here that's looking for a target object. Let's drag our player game object in there. Let it finish compiling. And there you go. So now our target is our player. And if we run this, our main camera is now always going to be center focused on our player. And you can see it adjusted itself. Now, as we play this and we switch our camera views, it's going to maintain looking, and we're going to get this awesome pan effect as we progress through the level. Very, very cool. And you can see here that as we walk up the stairs, we're not going to have any other issues because it's always going to be looking at our player. And there you go. We get this nice natural pan effect that I think works really well for this game. And now we can make it all the way to the main vault. And what you want to do is you want to make sure that all of your camera triggers are correct. In the meantime, we're just going to walk through all of these camera detections. We'll be setting these up later in the course. Let's go ahead and make our way up to the vault here. Past the guard, we'll trigger the cutscene here. Make sure you can get up all the stairs. Let's go up the stairs. And there we go. So everything is working really, really nicely. Hopefully you guys also enjoy this dynamic camera movement system. I'll see you guys in the next video. In this video, we're going to start the process of swapping out our 3D capsule for our 3D model Darren and begin going through the animation process. The first thing we want to do is select our player, and we want to set this back to the defaults so that when we bring Darren in, it should map just fine. The first thing we want to do is we adjusted the scale of this capsule. Set that back to 1 by 1 by 1. The next thing I want to do is I want to make sure that everything is adjusted okay. And let's go ahead and hide our mesh renderer so that it's just our capsule colliders and our nav mesh agent. From here, I want to go into our prefabs folder, and inside here you have a Darren 3D game object. Drag this into the player game object so that Darren becomes a child object. Darren may be extra big, he may be a little large here, so what we want to do is we want to modify him to be about, let's try 2 by 2. So 2 by 2 may be too small. So instead, let's bring them up to about 3 by 3. Okay, and I'd say that looks pretty good. So the first thing that we want to check now that we have Darren here is if you click on the player game object, you want to make sure that these colliders are mapped around him okay. You'll see here that they aren't, and it's going to require a little bit of work. So the first thing we want to do is let's modify the capsule collider. So we're going to increase the radius of this capsule collider so that it fits around Darren. And then let's also increase the height. Okay, and we can adjust the height of this. So on the center, we'll bring it up. We just want Darren to be able to collide with objects. And we can go ahead and adjust the X center. So go ahead and center this on Darren. So let's set that to 0, and let's move it a bit forward. Okay, so I'd say I'm happy with this. That's pretty centered on him. We can decrease the height just a bit. Perfect. From here, you also want to make sure that your nav mesh agent is proper. So if you adjust the radius of your nav mesh agent, you'll be able to see where it is. You want to make sure that this also is around Darren's feet. And we can also increase the height of this. Now, I believe in Unity 3D that the nav mesh agent actually acts as a collider. So if you wanted to, you can actually delete this capsule collider component by right-clicking it and hitting remove component. To make sure our changes are okay, let's save our scene, run our game, and it should look like Darren is just kind of sliding across the floor. Go ahead and let it run. And here we go. So we have Darren sliding across the floor, and I do not see our triggered events happening. So there's a good chance that we actually do need that capsule collider. So we're going to add that back. So on here, we're going to add a capsule collider, and it should map around Darren just fine. If it didn't though, you can go to the radius. Let's increase the radius, increase the height, and we can increase the center position of it, just so it gets around Darren. Okay, so we're back to where we need to be. From here, let's go ahead and test this out again. I noticed that Darren looks a little small. He looks kind of like a miniature statue sliding across the floor. So what we want to do instead is we're going to keep the game in play mode, and let's find a good height. We want him ideally to be the same size as the security guards. So to change him, let's go into the player, click on Darren 3D, and let's adjust his scale to be about 4 by 4. And I think that looks a lot better. Let's see. I'd say 4 by 4 is pretty good. If you wanted to, you could probably go maybe like a 4.5. But that may be too big. So I'm going to go ahead and keep it at 4 by 4. All right. So let's go ahead and stop running. Select Darren, make him a 4 by 4 character. All right, and test it out one more time. And we should be good to go. Go ahead and run it. Okay, and I'm happy with that. I think that looks good. So in the next videos, guys, in the next set of videos, we will be animating Darren and setting up his controls through script. Now that we have Darren set up as a 3D model, let's go ahead and check out how we would create the animation controller for Darren. If you open up our game folder, inside here we have a folder called animations, we have character, we have Darren and guard. If we hop into Darren, we have 3 animations for Darren. We have idle, we have throw, and we have walk. What we need to do now is we need to create an animator component or an animation controller so that we can actually work with these animations. So to get started, the first thing we want to do is create a new animation controller. So to stay organized, let's hop into our animations, our character, hop into Darren, and let's create a new folder called controllers. And actually, you know what? We can actually put this directly in here as we only have one controller for Darren. So right click Darren's folder, create, and we're going to create an animator controller. Call this Darren. The animator controller is what's going to allow you to switch between the animation states, such as throw, idle, and walk. If you double click this controller, it will bring up the animator window. The animator window is where we can actually set up our animation states and create logic in here that we can then trigger through code. If you don't, if for whatever reason double clicking this did not open up the animator window, you can also go to Window, Animator, and that will also open this window. All right, so here we are in our animator component for Darren. The next thing we want to do is we want to actually hook up these animations. So let's go ahead and drag our idle animation first. And as you can see, the idle animation from entry to idle, and it's highlighted orange because this is the default animation. If we just run the game, nothing's going to happen right now. And the reason for that, and actually that's not true. If we run this game, you'll see here that the idle animation should be running. And it actually might not because this controller isn't actually on an object. So to make this work, we need to actually select Darren. We need to go to the Darren 3D model, and we actually need to add an animator component. From here, you can see here it's looking for a controller. Drag Darren's controller from the project view into the animator slot. Now that Darren has a controller assigned, we can go ahead and save our scene, run the game, and we should see that Darren is now animating an idle. And there you go. If you select the animation, you'll see here his idle animation is playing and it's looping. If we look at Darren, he should be having a sort of breathe effect and his arms are moving, and they are. So that's how we set up our idle animation. So what we can do now is we can drag in the other animations. We have a throw animation and we have a walk animation. And we're going to have to create transition visual logic to create when to go from walk to idle and when to go from idle to walk and idle to throw or walk to throw. All right, so let's go ahead. In the next video, we're going to set up our walking transition behavior state. Let's create the animation behavior from idle to walk and back to idle. Now, later in this course, we are going to make use of this throw animation, but that's going to be dedicated to another section. So we want to focus on just the player movement of switching from idle to walk, walk to idle, and only play the walk animation when we're actually moving. The way we do this is we first need to create some visual logic. So we know that idle is going to be the default case, but what happens when we actually click somewhere to begin walking? We need to then say transition by making, if we right click, we can make a transition to walk. And from here, once Unity lets me do this, from here we want to make a transition to walk, and we're going to walk to idle. And when should we go to walk? We should transition from idle to walk when we actually are walking, which is when you click on a floor space, right? We want to be able to basically say, hey, let's walk. So we can use a parameter to control that walking. And we want to make sure that exit time is off so that we can instantly snap back to idle and walk. So if we select here, exit time is off. If you have an exit time, that means that the animation has to finish playing before it can go back to either or animation. So the first thing I want to do is I want to add a parameter in here. And this parameter is going to be a bool, and it's going to be walk. So basically, when this bool is true, so we're going to trigger that bool to be true through code. And when it's true, what needs to happen? We're going to say here, when walk is true, we're going to go from idle to walk. And when walking is false, which means we're at our destination, we need to then set false, or we need to then set walk to false. So just like that, walk to false. And when walking is set to true, we go to walk. When walking is set to false, we go back to idle. So that is how we set up the behavior of the animation. You can save your scene. And the idea here is that if we play this, we're going to start off in our idle position, and we can actually see this in the scene view. Let's go ahead and click to where we can see our player. You'll see here that he is in his idle position. You can see his hand moving. And if we trigger this to be true by just clicking it in the inspector here, you can see here that he switches to his walk animation. Now it looks like there's an error here called animation event soft walk has no receiver. Are you missing a component? So I've never actually seen that before. Let's check something. So let's look at the walk animations. All right, it transitions to the walk just fine. I'm actually not 100% sure what that is. I've never seen that. So when you encounter an issue like this, where you have 3D animation event soft walk, let's open up our inspector, or I'm sorry, our console. Darren 3D animation event soft walk has no receiver. Are you missing a component? So let's copy that error and take it to Google. So if we go into Google here and we paste that error, player animation event new event has no receiver. And you can see here there's some answers. You probably did add a animation event named new event on one of your clips, but you didn't add the mono behavior on your game object with a function to answer this event. Select your animation clip asset file and remove any event that shouldn't be there. So let's see here. Select your animation clip asset file and remove any event that shouldn't be there. So if we select our animation clip, which is walk here, I don't see any events on it. What we can try here is if you select the walk animation and double click it, let's look at this in the actual animation window. So double clicking it is not bringing up the animation window, but if you go to window, animation, we can see our walk event here. And it looks like we do have some events. These are called soft walk and soft walk. So I don't know what these events are. They could have been something that was placed in the outside program. So what we want to do here is select them, delete them. So just select these animation events at these little horizontal lines here at the very top and just delete them. You can stop running Unity. You can save your scene. And if we run this again, everything should be okay. All right, so we're looking at Darren here in the game view. Let's go ahead. Right now he's doing just his idle animation. You can see his hand twitching there. And if we go to our animator view and now turn the walk bool to true, you'll see here that Darren is walking. And if we set it back to false, he's back to idle. So what we want to do is we want to control this dynamically through code. So I'll see you in the next video. Now that we have Darren's animator controller set up, we need to control it through code so that when you're walking, we set that bool to true, and when it's not walking, meaning that you've made it to your destination, we set the bool to false. So this is going to be a two-part challenge. The first challenge is getting it to work, and then the second challenge is going to be making it go back to idle. How do we know when we're at that destination? So the first thing that we want to do is, in order to access this animator controller, which has the parameters walk on it, and be able to set it to true, we need to gain access to this animator component. So from our player script, we need to get a handle onto the animator component. From there, we can then set the animation by just triggering that bool. So the question now is, how do we access that parameter? So let's go ahead and look at the animator component scripting reference in Unity. If we go to the scripting API animator, we have parameters here, public methods, and some of these methods here are set bool, set float, and I believe there's set int in here as well. So if we look here, though, we have set bool and set float, sets an animator bool parameter, and that's exactly what we're working with. So we created that bool walk. And what we want to do here is all we need to do is just set it to true. So how do we do that? You can see here that they're fetching the animator. So they're getting a handle to the animator component. They've assigned the animator component. From here, it looks like if they hit the space key, mjump becomes true. And then here, you can see that right here, here's how they're using this. So if mjump is false, they're saying animator.setBool, the parameter name, and then the value. So for us, the parameter name is walk, and the value is going to be true. So let's go ahead and write some pseudocode out for what we need to do. If we go into our player here, the first thing we need to do is we need a handle onto our animator component. All right, so get handle to animator. And this is important to know that the animator is in a child object of the player. We can't do get component animator because it's not on the same object. It's in a child object. So you need to figure out how to get a component from a child object. From there, what we can do is if we left click, if we hit something, if we say agent.setDestination do this, that means we need to start walking. So immediately after this, what we can do is we can literally call onto our animator. We can say set bool, and we want to say basically walk, and it's going to be true. So you need to set that bool in the animator to true, and it should automatically transition to the walking animation. And the next challenge will focus on stopping it. All right, so focus on this, and I'll see you in the challenge review. In this challenge review, we're going to look at how to create the walk animation. So for the first thing I need to do is I need to get a handle onto the child component. So if I look at my player here I am on the player script, and I need to get the animator component off the child object Darren 3D. To do this, what I can do is we can go to our code here. I'm going to create a handle as normal. So get handle to our animator. So I'm going to say private animator, and we'll call this underscore anim. And from here, I'm going to go into start, and I'm going to say underscore anim equals, and I'm going to say get component in children. And the component I'm looking for is going to be the animator component. This is going to go into the child object and grab the animator component. From here, I need to set the bool in that animator to true. So we're going to say anim.setBool. And you'll see here using the tooltip that it's looking for a name, the name of the parameter. And if you remember, we created the name walk in this parameter by adding this plus sign here and adding a bool. Okay, so I'm going to delete that one. So here we have walk, and we want to set it to true so that it transitions to the walk animation. So anim set bool walk, and we're going to give it a value of true. Let's save this and test it out. So as Unity runs here, we'll go ahead and look at the scene view. With the animator, here's our game view. So right now we're idling, and if I click, we are now walking. All right, and there we go. We have walking around our scene. Wherever I click, we walk to. Now you'll notice though that if I come to a halt, like I'm gonna show you here in front of the camera, we don't go back to idle. We're stuck in the walk state forever. So we need to now check. In the next video, we'll go over this challenge on how to check to stop walking. I'll see you in the next video. In this challenge, we need to go from our walk animation back to our idle. So what are what is the logic, right, for what we want to do here? I'm going to remove some of the comments we have here and clean up our code a bit. And in order for us to, we can keep this comment. So now in order for this to work, right now what's happening is we left click, we cast array. If we hit something on the floor, we're going to go ahead and say anim.setBool, and we're going to walk to that position. Now what happens after that? So immediately after this, we're no longer in that if statement because we're not pressing the left key. Now we're here, we're just in the update loop where we can now check if we've made it to the destination. So one of the things you can do is you can check to see if the transform.position, which is the player game object, you could check to see if the, you could check to see if player object is equal, if player object equals, say, the destination. So like the target, which is the hitInfo.point. So if player object equals destination, then we want to say anim.setBool, and that's going to be false. right? So that's one solution there. Another thing we could do is we can actually calculate the distance, and we can actually stop it a little sooner. In most games, when you're creating artificial intelligence, you'll actually use, because typically you're working with float values, and you're not going to get a precise player position equals destination. So another solution here is to actually calculate distance. So to calculate the distance, there's functions in Unity that you can research to help you calculate the distance between an object. Between two objects. So for instance, the transform of the player and the target position, which is the hit info dot point. So you can say, for instance, distance equals, let's say, distance between, we'll go ahead and say distance equals, and we want to know between player and destination. So once we get that distance, what can you do? Well, then you can check the distance. And you can simply check if the distance, is less than 1 unit from the destination, then you can stop animation. So that's another option there. So there's quite a few solutions to creating this. And what I want you to do is I want you to do some research on how you can solve this problem. We know what we need to do. We just need to stop it when we get to the destination or when we're almost at our destination. Switch back to idle. All right, so go ahead, give that a shot, and I'll see you in the challenge review. In this challenge review, I'm going to be going back to the idle animation using the distance. So the first thing that I want to do here is calculate the distance between the player and the destination. So I'm going to delete this. Okay, and actually we'll keep it as a guide. So first thing first, we need the distance. So distance is going to be just a float value that I'm going to look for. And it's going to be the distance between our player, which is our transform.position, and the destination, which is hitinfo.point. So to do that, I'm going to say float distance equals, and if you were researching, you would have found something that said vector3.distance. It allows you to put in the two positions, and it returns the distance between A and B. So for this vector3A, we're going to put transform.position, which is our player. And for B, we want to put hitinfo.point. Now, this isn't going to work. And the reason for that is because hitinfo is declared as a local variable inside of this if statement. I cannot access it outside that if statement. I can only access this within that if statement. That means that I now need to create a variable that's going to have a global status so that I can get this information that I need. So to do that, what I want to do is I'm going to create here a private vector3, and let's call this target. So private vector3 target. And what I'm going to do here is if we hit the floor and we're walking, we want to then go ahead and assign my target equal to the hitinfo.point so that I can use it outside of this scope. From there, I can now check between the distance of my transform.position and my underscore target. Let's save that. Okay, so from there, what we can do, and this is going to be calculated the entire time. From here, what we want to do is now that we have the distance, we can check if distance is less than 1, then stop the animation. So here we'll have an if statement. All right, really simple. So if distance is less than 1, if distance is less than 1.0f, then what do we want to do? We want to stop the animation. So we're going to say anim.setBool. We're going to set that walk animation, and we're going to set it to false. A comma. Don't forget your semicolon. Let's save this, and we can test it out. And I'm going to delete this code here. Okay, so there's our code. We'll go ahead and save that. Let's head back into Unity. Let's run it, and let's see how it looks. So here we are in the scene view, where we're in idle. If we walk, and actually that looks pretty good. I walk, we get to our destination, and we stop moving. So I'm actually very happy with that. And one of the things we can actually modify here, if you feel like the character is sliding a bit, one of the things that you can do is let me see here. One of the things that we can do is on the actual physical properties of Darren, and here, let me get him in front of the actual camera. So I'm clicking right here. Let's see how he stops. So he actually stops pretty accurately, but there are some things you can do on your actual nav mesh agent of the player. So if you select your player and look at your nav mesh agent here, you'll see things in properties, for instance, such as stopping distance. And that stopping distance is basically going to make it so that it stops when it's exactly at the target. What you could do is set this to say 1.5 and watch what happens. We change it and it will stop now 1.5 before it gets to that actual target. All right, so you can modify this and make it as smooth as you want. So it looks like it's actually pretty okay at 0. You can also increase the acceleration and the speed if you wanted to speed it up. How quickly does it reach that speed of 3.5? So, and I think for the most part, I think I'm happy with the speed of this. I think it's okay. But by all means, go ahead and play around with it. I'll see you guys in the next video. Before we head on to the enemy AI section of the course, you want to make sure that you've gone ahead, saved your scene, and commit your project. Let's go ahead and just say created player movement system. I'll see you guys in the next section.